Hello, Luke. Welcome to Lesson 79. So today we're going to be talking about systems of equations with subscripted variables. And we talked a little bit about subscripted variables before, but in future lessons they will be giving you story problems in which using subscripted variables just makes sense. It'll keep things more organized and prevent you from getting confused. So, for example, instead of having an equation such as x plus y is equal to 10, where maybe x is the, speed of Tim, right? Maybe that's what it is. And maybe y is equal to the speed of Tom, or we'll say speed of Pam. All right. If that's what the x and y represents, if we just were to use this equation and solve for x and y, sometimes it's easy to forget what x represents. Was x the speed of Pam, or was x the speed of Tim, or was x the time of Pam, or so forth, so on and so forth. So a better way to do it would be to write variables that make sense. Okay, so instead of using an x, I might use an r, which would stand for rate. So instead of the speed of Tim, we might call it the rate of Tim. Okay, so if I use r to represent the rate, and then I use a subscripted variable. So underneath this, I might write a capital T. And this would mean the rate of Tim. And then if I wanted to use rate, again, to represent speed, if I wanted to represent Pam's speed, I would use a subscript P to represent the rate of Pam. So I have the rate of Tim, and I have the rate of Pam. All right. These would be better choices for our variables than an x or a y. They just make more sense given the problem. All right. And we talked about subscripted variables before. So we could read this as, in full, the rate of Tom, or Tim, excuse me, and the rate of Pam. Or we could read them as the r sub t. Okay. R sub p, for example. Okay. Very straightforward. So that's really all we're talking about today, is just getting used to using subscripted variables in our equations. And just remembering that mathematically, when you see a variable that looks like this subscript t mathematically does not mean anything. It's not like an exponent or something like that. It is just a way to write a variable to keep them all straight. All right. So in future lessons, we will be talking about equations that deal with rate and time. Okay. Sometimes we'll be talking about things that deal with distance too. But for right now, we'll just kind of think of them in terms of rate and time. All right. And what they'll be doing is giving you a bunch of equations in which you need to solve for the rate and the time of particular people or animals or things that are involved in the story problem. So you'll see a lot of variables that'll be written as r sub t or r sub m or r sub, d, whatever the name was for the person in which we're describing, or for which we're describing the rate. We would use their first initial as the subscript. So this might be the rate of Mary. This might be the rate of Dan, for example. You'll see a lot of T's as well. So you might have T sub P. Maybe that's the time of Peter, okay? Or T sub, C, the time of Charles, okay? So you're going to be seeing these variables a lot. So they just want you to get used to those. And so for this particular lesson, they're just going to give you a bunch of equations with subscripted variables and then ask you to solve for those subscripted variables. All right, so they won't actually give you the story problem now. They will give you the story problem later. All right, so this is an example of what you'll see in your seat work problems. They'll give you 4 equations. All right, they're all subscripted variables. So we have t sub p is equal to 4, t sub a is equal to 3, r sub p is equal to 50. And then we have this nice long equation here, the r sub a times the the t sub a plus the r sub p times the t sub p is equal to 320. All right. So bottom line, they're giving you 4 equations, and then they're going to tell you to solve for the variables. The variables t sub p and r sub p. and t sub a, and r sub a. So we have 4 variables here. All right. And just as kind of a rule of thumb, in order to solve for variables, generally, if you have 4 variables, that would indicate that you need 4 equations. All right. It's kind of a nice general rule of thumb. If there were 3 variables that you were trying to solve for, you would generally need 3 equations to solve for that. If there are 2 equations, well, or 2 variables, well, then you need 2 equations. And of course, if there's only 1 variable, then you could get by with just 1 equation. But in general, if you see 4 variables that you're solving for, you're going to need 4 equations with those variables. Okay, so we do have 4 equations here. We have 1, 2, 3, and 4. Okay, so there are our 4 equations. Now we're going to go ahead and solve for these equations. And to do so, we just need to look through these and just decide a strategy that we're going to use. All right, all of these will be a little bit different, so you need to kind of use your head and just strategize the way to do it. So let's look at it. We have t sub p is equal to 4. Well, there you go. We already know what t sub p is. They tell us right off the bat. T sub a is equal to 3. Well, there you go. We've already solved for that one. Look at that. Half the work already done. They already told us what t sub a is. It's 3. And then r sub p, well, gosh, oh golly, they've already told us that as well. R sub p is equal to 50. So 3 of them are already solved for us. The one that we need to solve for is the r sub a. That's the one they didn't give us. That's where this big equation here comes into play. So to solve for r sub a, we're going to use this equation, but we're going to plug into it everything we know about these other 3 variables. So for example, r sub a, we do not know. So that's just going to remain a variable, r sub a. T sub a, we know what that is. A t sub a is a 3 based on equation number 2 here. So we can replace that t sub a with a 3. All right, then we have our plus sign. And then we have r sub p. Well, again, that can be replaced with a 50. And then we have t sub p. Well, that can be replaced with a 4. And then that equals 320. So there we go. We've been able to plug all of these other 3 equations into this 4th equation, and that leaves us with an equation with only 1 variable, which is the way that we want it, because now we can solve. All right, so if we multiply this out, we have 3 r sub a plus, what's 50 times 4? That's going to be 200, equals 320. We can subtract the 200 from both sides, right? And if we do that, we end up with 120 on our right and a 3r sub a on the left. We can divide by 3, and we're left with r sub a is equal to 40. So there you go. We have solved for the r sub a now. So everything is taken care of. We know what each variable means, and we're good to go. All right, so let's try another one. Go ahead and try this one on your own. See how well you do. Again, they've given us 4 equations, so there are 4 unknowns here. And 3 of them, they were kind enough to give us, well, I shouldn't say that. 2 of them, they were kind enough to give us a nice, clear answer as to what they are. But the other 2, you're going to have to solve for. So try this on your own and see how you do. And then if you didn't get it, that's fine. We'll be going through it together. All right, so let's see how you did. So to begin with, we already know what RT is, R sub t. We already know what R sub R is. We know that T sub t is equal to T sub R, but we don't know what either one of those are. And then we have R sub t and the rest of this big equation right here, right? So the strategy here would be to find the equation in which we can actually do something, right? So this first one here, T sub t equals T sub R, there's nothing we can do there. We can't plug anything into this equation because we don't know what either of these variables are. So if we go to the larger equation here, R sub t, we do know what R sub t is. T sub t, we don't know. R sub R, we do know. T sub R, we don't know, but there's a trick here. We do know that T sub R is equal to T sub t. So we kind of know what it is. All right, so we're going to go to this large equation, and we're going to start plugging things in. So R sub t, again, we do not know what that is. T sub t, oh, I'm sorry, whoops. We do know what that is. R sub t. R sub t is equal to 2. So we can replace that with a 2. T sub t, we do not know what that is. So we'll leave it as our subscripted variable. Plus 120 equals r sub r. We know what that is. That's a 10. Times t sub r. Now this is where it gets interesting. Now I could just say I don't know what t sub r is, so I'm just going to leave it as t sub r. But I could also say that t sub r, I do know that it's equal to t sub t, right? So this isn't a number. However, it is an equality here. T sub r does equal t sub t. So if I replace this t sub r with a t sub t, the benefit there is that I am then creating an equation in one variable. See, now we've got t sub t over here and a t sub t over here. If I would have just rewritten it as t sub r, I'm still kind of stuck because I've got one equation with two variables in it, t sub t and t sub r. Okay, so what we need to recognize here is even though we don't know the number behind this t sub r, we do know that it's equal to the t sub t. So I can replace or plug into t sub r a t sub t. All right, and that'll give me the same one variable in my equation. So it's a little bit of a trick there, but hopefully you can see how that works. And then from there, it's just a simple process of solving for t sub t. So we'll move the t sub t's over to one side. I'm actually going to move this one over to the other side. T sub t, keep things positive here. -2 t sub t. And that's going to give me a 120 on the left and then an 8 t sub t on the right. I can divide both sides by an 8. And what's that going to give me? It's going to give me t sub t is equal to 15. Am I right? You can go into 12 once. So you can go into 45 times. Yeah, t sub t is going to equal 15. All right. Now, that's t sub t. We already know r sub t. We already know r sub r. We do not know what t sub r was. They didn't give us that. But they did tell us that t sub r is equal to t sub t. So if t sub t is equal to 15, then I can say that t sub r is equal to 15. There we go. So that is our solutions. We've now solved for all of the variables in the equations that were given to us. All right, let's try another one. Try this one on your own, and then we'll try it together. All right, so once again, and you'll find this is common in most of these problems, we tend to kind of target the larger equation here with all of the variables in it and use the other three equations to kind of plug in to that larger equation. So let's jump to this large equation. What's the r sub L? Do we know what that is? R sub L. Well, yes, we do. R sub L is 40, right? So we can plug that in. So we have a 40 being multiplied by t sub L, which we don't know what a t sub L is. Okay, so maybe we'll just write that as a t sub L. Okay, equals the r sub S, which we do know, that's an 80, times the t sub S. Now this is where we have to be a little bit creative again, because we're going to recognize here that if I just plug in t sub S right here, because I don't know what it is, you know, I do know that it's this though. But just, you know, if I just plug it in because I don't know the number, it's not going to help me because then I still have two variables, right? So what we want to do is plug in what we do know about t sub S. And, oh, sorry about that. Don't know where that came from. So we do know that t sub S is equal to t sub L minus 5. And the benefit of there is that this t sub L is the variable that's over here on the left as well. So then we'd have it all in one variable. So we're going to replace this t sub S with this whole thing here, this t sub L minus 5. Now be careful, because we're plugging this whole expression in, we're going to put it in parentheses, t sub L minus 5 as one unit, okay? All right, now we can solve this equation, and to do so, we're going to distribute this 80 through first. So 80 times t sub L is going to be 80 t sub L. 80 times a negative 5 is going to be what? 400, negative 400. All right, so now I have 40 TL over here, t sub L over here. Now we'll just do a little rearranging here. I'm going to subtract the negative 40 t sub l over here. Subtract it from this side. And then I'm also going to add the 400 to both sides as well. Okay. Eventually you should be able to do this adding and subtracting part in your head. So if you can do that already, that's great. You don't need to write all this out. But just to be thorough, I'll write it out. These are going to cross cancel. We're going to end up with, or cancel out, I should say. 400 is equal to 80 minus 40, which is 40 t sub l. These cross out. And then we're going to divide this out. So we have this side divided by 40, this side divided by 40. Zeros will cross out. 40 divided by 4 is 10, is equal to t sub l. So t sub l is going to be equal to 10. Now, what do we not know still? We still don't know what t sub s is. It's the only other variable, but we do know that it's t sub l minus 5. So we're going to plug that in. So we have t sub s is equal to t sub l, which now we know is a 10, and we'll subtract the 5 from that. And we end up with t sub s is equal to 5. So at this point, we've got all 4 of our variables and their respective their respective values. All right, very good. Let's try another one. Go ahead and pause the video, try this one on your own, and then we'll do it together. All right, so let's see how you did. Again, they gave us a couple of obvious solutions here, one that's maybe a little bit more complicated, and then the one that has a bunch of variables in it. So we're going to jump to the one that has the bunch of variables in it, and we're going to see what we can plug in. So r sub f, well, we don't know what r sub f is, so we'll just write it as r sub f. And then we have t sub f, well, we do know what that is. T sub f is equal to 16, so I'm just going to write that on this side, though. It's r sub f times 16, but I like putting the coefficient out in front. So it'll be 16 times r sub f equals r sub e, which we know here in terms of r sub f. So I'm going to actually plug in r sub e in these terms because I like having the r sub f as my variable. So instead of r sub e here, we're going to have the r in parentheses, r sub f plus 15. We're going to plug that in for that r sub e. And then lastly, we have t sub e, which they did tell us over here is a 12. All right, so now we can actually do some multiplication and simplification here and solve for r sub f. So we have 16 r sub f on the left. On the right, we're going to distribute the 12 through, so we're going to have 12 r sub f plus 12 times 15, which is 180. All right, then we're going to subtract the 12 r sub f from both sides. I'm going to do this in my head, just so we can see how you can kind of do it. So if I subtract 12 r sub f from both sides, I'm going to have 16 minus 12 is a 4 r sub f. This 12 is gone. I subtracted it out, equals 180. Now I can divide both sides by the 4, which is going to give me r sub f is equal to, what can that be, 45. So r sub f is equal to 45. Okay? The only thing left to solve for is r sub e. We have the t sub f and the t sub e. So r sub e is going to be equal to r sub f, which we now know is 45, plus 15, which is going to be r sub e has to be equal to 60. And there we go. We have all 4 variables taken care of. All right? Very good. So hopefully this makes sense to you. It's really not complicated. It's just essentially using substitution to solve for 4 equations. And those equations have variables in them that are subscripted variables. And that's just a new way to see variables. There's really no mathematical process that we need to think about for the subscripted variables. All right. And again, we will be using these later in story problems where you will actually have to pull out of the story problem these 4 equations so that you can solve for them. All right. Well, I think we'll stop here today. Good luck with your seat work, and I will see you tomorrow.